now. I'm just starting the recording. I have to find it. Oh, I'll get back to that. For today's presentation, we have Ivan Taylor once again presenting to the Canada chapter and all of our illustrious guests. Ivan Taylor has been a scientist emeritus at the Centre of Operational Research in the Defence R&D Canada, where he was employed as a defense scientist for over 33 years. Currently, Ivan is the president of Policy Dynamics Incorporated, located in Kitchener, Ontario. He has a PhD in public policy and a master's in information and systems science, on top of his BSc in mathematics with honors. So definitely an intellectual and a strong researcher. Ivan has authored a countless number of papers and presented within our INCOSE community at international workshops, at international symposiums, within various working groups, and most recently at last year's symposium in Dublin. And this year you were on, did you do an online one? I know you co-authored a couple.
Yeah, Ken Kierton presented for me.
Yes. So wonderful. It's great to have you, Ivan. I'll let you dive in with today's presentation. Please feel free to share your screen. Okay, there we go. Oh, good. We can see it.
Yeah, hi everyone. As Ivan Rodriguez said, I'm Ivan Taylor, the other Ivan on the board of directors of the Canadian chapter of INCOSE. I'm currently the treasurer of INCOSE Canada, and I've been a member of INCOSE since 2020. I'm a member of a couple of working groups. Primarily, I'm most active in the Resilience Systems Working Group and the Sustainability Working Group. So this work is inspired by the work of the Sustainability Working Group, who are looking at business models to try to find opportunities to make circularity and circular design profitable and make a business case for circularity and circular design. So the title of this talk is Designing Circular Products Customers Value. It's also hopefully going to be a paper submitted to the IS 2026, and hopefully we'll have something published on this. Okay, so this is maybe a little departure from standard systems engineering. It's more of a long-term view of how to look at circular design over a number of years, where you might release a product and then collect data on the product and then produce upgrades to the product to improve it. And so it's a long-term view. It's a very much a long-term view of a company producing a product and trying to improve it over time. So it starts out with systems thinking, which hopefully you'll understand or appreciate what I'm trying to do there. And then it gets into an exploratory simulation. And this is what I generally do is I do system dynamics simulations, and they basically look at behavior over time. And so it's always a behavior that you're interested in over a time period. And then I'll show you the baseline parameters that I used in the simulation and the baseline results. And then I'll talk about leveraging the parameters with constraints to do two things. I have one attempt to do a profit maximization, and the other was to try to balance profit and circular design. And then I have some conclusions. So here's the systems thinking model. It's kind of complex, and I don't expect you to really read it in detail. It's the letters are small, and there's lots of detail going on there with these loops. And basically, feedback thinking, loop systems thinking is feedback thinking. So basically, the idea is that you have cause and effect, which goes back to a cause. So basically, you have a cause creating an effect, and an effect creating a cause. So let's look at it in a little more detail. So we have these loops, and there's two types of loops. There's balancing loops, which I labeled B's, B1, B2, and so on. And then there's reinforcing loops, and there are R1 through R6. And balancing loops are basically seeking equilibrium, and they create a situation where an increase in something will ripple through the system and come back to the original origin and cause a decrease in that value. So it leads to an equilibrium. And a decrease in the variable will come back and lead to an increase in the variable. So basically, it's a goal-seeking situation. The reinforcing loop is more like exponential growth or exponential collapse. And basically, that involves a situation where an increase in a variable will return after a while to cause a further increase in that variable. So let's look at a few of these loops in detail. I'll just look at a couple. Echo efficiency I thought was interesting. So let's go back and look at echo efficiency. Okay, the echo efficiency is B1. So the idea here is that we have circular design, and circular design will lead to an increase. So S means that they move in the same direction. So if you increase circular design, you'll increase material recovery. And if you increase material recovery, you'll increase echo efficiency. And if you increase echo efficiency, you will decrease the pressure for systemic change. And if you decrease the pressure for systemic change, you'll decrease further R&D investment. And if you decrease further R&D investment, you'll decrease circular design. So like I said, you start with an increase in circular design, and going around this balancing loop, you end up with a decreasing circular design. So it's trying to achieve an equilibrium. Okay, so let's now look at a reinforcing loop. So let's look at R1, material recovery. Okay, so material recovery goes like this. You increase circular design, and that increases material recovery, which decreases manufacturing costs, which increases profit, which increases R&D investment, which increases circular design, and then further increases material recovery. So that's a reinforcing loop. Basically, an increase in material recovery leads to a further increase in material recovery because of the impact on profit. Okay, so now I turn this into, I operationalize this systems thinking diagram into an exploratory simulation. So I had to use sort of nominal data. I didn't have any concrete data on a product or a company, so I had to use sort of nominal data. But you can use this simulation to explore various things. And basically, you can think of an exploratory simulation as a thought experiment. So basically, it sort of tells you, sort of what if things. So what if you did this? What if you did that? And tries to test your assumptions and find the logical conclusions for your assumptions and your what we call your mental model. And the systems thinking diagram that we saw with the feedback loops was the mental model that I was talking about there. Okay, so the couple of things we're going to measure circular design, we're going to measure capital investment, we're going to measure performance and market adoption, material recovery, and interfirm trust in the supply chain. So I'm going to show you a couple of what's called stock and flow diagrams, which are the ways that system dynamics works to measure things changing over time. So the first one we'll look at is circular design, and we have a stock or an accumulation of circular design, which is based on increasing a flow in of building circular design and a flow out of circular design decay. And the way the circular design increases is through a combination of upgrades, design upgrades here, and R&D investment. So with R&D investment, and we can get improvements in circular design, and with design upgrades, we get improvement in circular design. So in terms of capital investment, this is pretty straightforward, but basically with more profit, we can have more capital investment. And with more capital investment, we can invest in products that we can lease to people instead of having people having to buy them. And by leasing products, we can reduce the upfront costs of the product, and that will increase the affordability of the product. So through capital investment, we can have an impact on affordability. And here's the systemic pressure to change. And we see here that we have this relationship between profit and R&D investment. And we have this eco-efficiency and pressure for systemic change. I guess one thing I should mention is that these gray values, these gray parameters here, are actually, this means that they're calculated on another screen. So this R&D investment is calculated using a formula that's a combination of these things. And when I have all capitals, that means it's a constant. And when I have all small letters, I mean that's a calculated value. And when I have this grayed out value, it comes from another screen, another part of another submodel. Okay, so here's performance. And again, performance is based on design upgrades, so we can improve performance based on design upgrades. We have market adoption, which allows you to collect performance data. And then with the performance data you can figure out how to upgrade the product, and then you can improve the performance, and that leads to improved customer satisfaction. And here's market adoption. So market adoption is based on performance and affordability. So the combination of performance and affordability leads to an adoption rate, and that's basically the units that are sold per month or per year. And market adoption is the total number of products in the system at any point in time. Okay, here's the profit now. So profit is based on the adoption rate, which is the sales, and customer satisfaction, which influences the sales. And then we have manufacturing costs, and manufacturing costs influence the price because we use a markup on manufacturing costs, and then price leads and sales leads to revenue, and manufacturing costs and sales leads to expenses. And then revenue minus expenses leads to profit. And then we have a material recovery. So circular design leads to improved recovery and improved eco-efficiency. And so that's material recovery. And then the interfirm trust is on logistics. So this interfirm trust is the supply chain. And then that leads to cooperation in logistics. And then cooperation in logistics influences the manufacturing costs. This is, like I said, the supply chain, and the supply chain for maybe material recovery. Then we have manufacturing costs are influenced by a learning rate, and the learning rate is influenced by the market adoption. So the more products in service, the more learning we can have, and therefore the reducing the manufacturing costs. And raw materials are important because that's basically the reason that the manufacturing costs are what they are, is because you're using raw materials. Now, raw material prices are influenced by virgin material demand. And basically, that's what we're trying to do in the circular design. We're trying to reduce the virgin material demand. Okay, so like I said, I tried to operationalize all that into into a system dynamics model, and those all those variables that I mentioned with capital letters are all parameters of the model. So there's actually turns out to be about 50 of those capital lettered parameters, and those parameters can be experimented with to see how they influence the results. So there's 50 parameters in total. And when I took the baseline case, which is basically the nominal situation based on sort of what I understood to be sort of standard practice today, I got this kind of result here, which showed that we were improving material recovery through circular design. However, we were only having a limited impact on customer satisfaction. And so that led to a situation where based on market adoption and the pricing system, which is based on the markup of manufacturing costs, we end up with a situation like this where we have a short-term gain in profitability because of increasing market adoption. However, with the saturation of the market, then we eventually see that we end up with a declining profit. However, there is some good news at the end of this period. It looks like it's starting to increase again. So it might have reached a bottoming out period there. And here's the retained earnings. So this is, I'm going to now go through this and I'm going to try to maximize retained earnings when I do the next process. So what I did is I looked at leverage points, and leverage points are places where small changes can have big impacts. Oh, and so I looked at leverage points, and these are the leverage points I was able to identify. I show the parameter here on the left-hand side, the current value of that parameter, the minimum value, and the maximum value that I would expect this parameter to have, and then a rationale about why I thought this was a possible leverage point. And so what I'm going to do is I'm going to do what's called a constrained optimization, and I'm going to try to optimize retained earnings by varying these values, these leverage points, within these constraints of minimum and maximum values. So then I have also secondary leverage points, and these are other leverage points that we could look at. And again, I show maximum and minimum values, and then a note about what does this leverage point mean. And this is what I got when I maximized retained earnings over the 10-year period. So here's the profit, and you see that it's basically what's called in system dynamics terms an overshoot and collapse. So basically, we have a very rapid increase in profits, followed by a peak and then a decline to some kind of equilibrium, which is slightly lower than the initial value. So that's a common thing that you find in system dynamics is basically it's you get rapid growth, and then you reach a limit, and then you find that because you've reached that limit, you now have I wouldn't call it a catastrophe, but you have a collapse of the situation. So here's the results in terms of customer satisfaction and material recovery. So when I did the profit maximization run, I found that customer satisfaction was decisive. Basically, customer satisfaction grew very quickly and to a very high level, and so that led to this rapid adoption of the product. However, with in the profit maximizing scenario, it didn't we didn't seem to achieve much material recovery. And so that leads me to believe that maybe a profit maximizing firm may not be all that interested in a circular design. Here's the retained earnings that when I after I maximized and yeah, so this is you show that you see you have quite a large retained earnings. Now, the next thing I did is I said, okay, let's combine retained earnings and material recovery, and try to get both of these things at the same time. So this shows that again, when you're maximizing retained earnings, you have basically the same picture of customer satisfaction. So customer satisfaction grows quite quickly and reaches the limit of 100%. And then when we also bring in material recovery, we see that we get a very nice increase in material recovery, which shows that we're getting very close to a circular design. And then we can look at compare the profit in these two scenarios, and we can see that in the profit maximizing scenario, we get a higher profit. However, in the balanced scenario, we still get a very good profit, not as high as in the profit maximizing situation, but still it's quite substantial, and I think that's a good thing. So here's the retained earnings, and we can see the retained earnings are much higher in the profit maximizing firm. However, the retained earnings in the balanced situation are pretty reasonable as well. Okay, so that basically is my presentation of a thought experiment. So basically, I'm talking about an exploratory simulation which operationalizes systems thinking. And basically, I think of this as a thought experiment, and it's not a forecast. So basically, based on the assumptions that we had in the systems thinking model, we were able to operationalize that model and then run thought experiments using that system, that simulation. And what my conclusion is that what it suggests that today circular design alone may not improve profits. However, and therefore, profit maximizing firms may not be interested in circular design. However, firms interested in circular design can make a profit by providing what customers care about, and that is performance and price. And then policy implications here, my company is called Policy Dynamics, so I'm always looking for policies. So circular design may not pay off until the government prices waste, such as carbon and landfill taxes, and encourages reuse, rewards reuse through investment tax credits and point of sale rebates, and possibly funds innovative design, such as grants promoting modularity and commonality. So thank you for your attention, and I'm open the floor to questions and comments. You can reach me at any time at either of these email addresses, and you can participate in further studies in this with our team.
Wonderful. Thank you, Ivan. Yeah, I think we have with this group, we can just go open mic. Please feel free to ask your questions. And if you would rather that I ask your question on your behalf, you can type it in the chat. Yeah, go ahead, Ken. Start us off.
Okay, I was going to ask Ivan, is any of this applicable to organizational resilience?
Organizational resilience.
Yes, the resilience of an organization itself. You kind of intimated that some of this may be of value to profit-making companies to understand certain things.
Yeah, I think, well, first of all, that's a good point. And I think that basically what I'd like to do for that is probably generate a new systems thinking diagram for something like organizational resilience and how organizational resilience would impact profit. And then I could then operationalize that systems thinking view, and then I could see if we could maximize profit, how that would affect organizational resilience. And also I could look at if you maximize organizational resilience, how that might impact profit. So yeah, let's think about that, Ken, and we can uh, we can look at another model. Basically, we would use the same process that I presented here for a slightly different goal.
Okay. John Burtis, did you want to add anything to that? Notice you also have your hand up.
No, no, I had a question.
Go ahead, John.
Yeah, go ahead, John.
Yeah, the thing I'm wondering about, and maybe I missed it, uh, are you in any way modeling the effect of being in a competitive marketplace, where if your price, if your profit is lower, well, the bottom line is, you're focusing on the profitability, but one of the critical issues in a marketplace is your price and the price that you have to charge the consumer, and the effect of being literally non-competitive. No matter how happy the consumer is with the product, if they can get the same product for half the price, you're going to go out of business. And I didn't see that in the model.
Yeah, it's implicit, I think. Sorry, that's a good question, though. Like, thanks for raising that, John. It's sort of implicit in the model. Basically, the profit maximizing firm in this case would try to produce a better product at the same price and try to get people to keep buying their product because it's better. So you can sort of think of maybe the car industry where
But they,
they
yeah,
keep the prices. The price may go up, but you're getting a better product. So that's sort of what they're
but
thinking of. Go
but
ahead.
wouldn't they also be able to maximize their profit by driving you out of business because your cost of production is so much more?
Yeah, that's the other side of it is that the circular design company
Mm.
can reduce their manufacturing costs and pass the savings on to consumers through the price markup. So basically, the model suggests that price is a markup of manufacturing costs. So if you can reduce manufacturing costs, you can reduce the price, and then that will create a good dynamic for market adoption.
And a profit maximization could also organization could also be a price minimization organization
Yeah,
by
definitely. Yeah,
yeah.
definitely. There's like I'm having a bit of a problem with the members of my team who don't like the idea of price reductions in this work. They don't think they're realistic. And one of my colleagues believes that the only reason that you would have drastic price reductions, as this model suggests, is to drive your competition out of business
or
and then become a
alternately
monopoly and become a
or
monopoly.
alternately to increase your sales.
Yeah, that's right. And that's the market adoption side of it. So
And
yeah,
that's one way of increasing profit by
yeah,
increasing sales.
yeah, that's right. That's right. And I guess the issue I had is that I had a finite market for this product. and so you reach market saturation, and then
Hmm.
all you're really doing is replacing things that are being used up. So so yeah, if you can expand your market by drawing in customers that wouldn't necessarily buy your product, and you could keep growing your market, that would be a slightly different dynamic than what I'm showing here. Basically, well, I think if you go back to one of my slides, you'll see I have something called potential customers or potential market, and
Ah,
that
yes.
and that's a limitation on the market. So basically, you reach you reach market saturation at some point, and then it depends on how quickly you reach market saturation, and and maybe you could slow down this reaching market saturation to try to build up the market and gradually as well.
Okay. Well, thank you. But yeah, very interesting work.
Thank you. Thank you.
Ivan, I've got one for you. So kind of uh, levers off of John's comments and questions. Um, so a lot of times you'll do a price reduction. Sometimes it's for the market to increase sales, as you mentioned. Quite often, what I've seen is the price reduction is a very positive byproduct of component obsolescence, where you're forced into a redesign or just even a replacement, even if it is a form, fit, and function replacement pin for pin of a component, and the result is a price reduction. Um, I'm just wondering how you would model that, and also have you considered um, price reduction? What was I going to ask? Where well, first off, answer that one. I'll think of my second
Yeah,
question.
you'll have to repeat the question. I didn't.
Okay, so a price reduction with respect to, if, for example, component obsolescence. So in your circular design, if you're doing a life extension, for example, on a product, taking care of component obsolescence, whether or not it results in a price reduction, does that have a place in your model of
Um,
circular design?
yeah, that's great. That's a great idea, and it does have a place in my model because I have sort of this abstract idea of design upgrades.
Yes.
And basically, design upgrades are based on information that you get from customers who have your product, and then you
Mhm.
can make design upgrades to improve your product. So those
Okay.
design upgrades could include life extensions or
Hmm.
improved reliability, improved availability, improved all kinds of different abilities.
Okay. Another question. There's price reduction, but maybe instead of price reduction, we do a feature enhancement. So add features, improve features, essentially anything value added
Yeah.
at the same price.
Yeah, that's basically, I think, what I tried to get at with the profit maximizing firm.
I see. Okay.
Profit maximizing firm, when it increases customer satisfaction, the way
Yes.
it does that is by doing design upgrades that will enhance the product.
Okay.
So
Okay.
that gives you customers more and more satisfaction.
Okay. So more
However,
than bug
however,
fixes, more
those
than
people
component
are not,
obsolescence.
the profit maximizing firm is not reducing prices. They're focused completely on design upgrades that improve performance.
Okay. Yeah, John, go ahead.
Yeah, another question, and I'm really curious. I could imagine that there might be a scaling uh, effect where below a certain scale, the circularity doesn't make sense. But if you get to a higher scale in terms of the number of products, the circular model does become a
Mhm.
profitable possibility. Is there any knee in the curve or a tipping point where the scale of uh, the of production, let's call it, uh, determines when the circular model becomes viable?
Are you talking about multiple products, or are you talking about multiple products in service?
Well, a single product. I can
Your
imagine,
product.
when you scale the number of units of output for a product, the price usually goes down. And I could imagine that that would also be true of circular activity, that the more of it you do, the lower the cost per unit might become. And so scaling might become an important issue.
Yeah. Yeah, there is in the model, there is this learning effect that's based on market adoption. So the more products in the market, the more learning you do, which is good. And there is definitely a knee in the curve in the model that leads that basically says, as you reach market saturation, then what you'll see in the model is basically a rapid increase in the market adoption, and then a knee in the curve, as you say, as it starts to reach market saturation. Does that answer your question, John?
Yes, yeah, it does. And if I may, just to put in a positive thing for engineering using engineering principles. Engineering principles are a form of a learning curve. If you can use engineering principles, you move yourself way up the learning curve that you're modeling there. And so maybe you should include the use of engineering capability in the model.
Yeah, 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 I agree with you, and I think it is implicit in the model, because this is over 10-year period, and as I said, I have this sort of abstract idea of design upgrades, and those design upgrades are sort of implicitly based on engineering principles that you learn, and you do new designs that are provide better performance. I don't have a lever per se. Well, sorry, I do have a lever. I have something called circular design gain. And so, basically the gain can be modified to measure possibly what you're talking about. So basically, you gather data from customers, you try to do a new design, and basically you based on this design upgrade gain, you can do better with the data. And maybe that's a place we could fool around with to say, okay, maybe design gain could be modeled as higher or lower amounts of professional engineering.
Interesting. Yeah. Yeah, that'd be worth exploring. And by the way, there is even a section in the handbook where they talk about the benefit of applying a certain level of systems engineering to complex systems. And there's some empirical data in there that I recall. You may be able to pull from that.
Yeah, I'll have to look into that. Yeah. Yeah, I think, this model, as I said, there's 50 parameters, and all of those parameters are like moving parts. So, it is quite complex, and I tried to constrain it so that I didn't have everything moving at the same time. But still, I think there's lots of room for experimentation and exploration, like I said. Well, thanks, John. That's great. Like I said, I think it's implicit in the model. I don't know if I actually tried to optimize it.
Mhm. Any more questions, comments,
Yeah,
experiences?
Ivan, your goal is sustainability in the end. Um, and so you're talking about the use of the Earth's resources. And, there are different resources depending on your product, whether it's water and how much water you need, and whether there's a shortage of or not, or whether you're using rare elements, and is there a replacement for them? And so I don't know if you look at it from that perspective, the goal would be to basically not use more Earth resources, but less. And so you're trying to optimize that as
Yeah.
much as
Well,
possible.
that that is, that
And there are constraints, of course, in terms of it's not at any cost, but there may be some cost, and in some cases, it may be just the ability uh, to get a resource, um, because there are limits.
yeah,
Um,
yeah.
uh,
Well,
and and as you say, you may get sometimes you may even get a savings, but the real key is the ability to do using less of the Earth's resources. And
yeah,
so
that in my model, sorry to interrupt, Ray. In my model, I have this concept of virgin raw materials,
Mm.
which are basically, you're using those virgin raw materials uh, to some extent, and then you have material recovery to replace the use of, say, some virgin raw materials. So the virgin raw materials are like the resources that you're extracting, uh, and then the material recovery are the resources that you're getting back. And if you can get more material recovery, you need less virgin resources, virgin
And
material.
that should build itself in, or should find its way into your gain calculation, should it not? Because I guess arguably you should only be taxed once.
Yeah, yeah. Well, like I said, the idea is that through design upgrades, you get better circularity, you get better material
Mhm.
recovery. That reduces your virgin raw materials price, your raw materials needs, which then can reduce your costs. And so hopefully by reducing your virgin raw materials, you can reduce your costs and therefore reduce your prices.
Now, out of curiosity on that one, Ivan, just to provide some argumentative philosophy on that one. Um, with respect to the Earth, yes, I think it's a lower cost. Now, what about supply and demand? If you're not drawing from that virgin resource, could the price go up?
it might,
Yeah, I
and the customer will in fact tolerate, some price increase, uh, believing in that, we have to. Uh, we've got limited resources,
Mhm.
and I'm willing to contribute to it.
yeah, I'm not sure your point, Ivan. Can you sort of
Well, yeah,
rephrase it a little bit?
I guess I'm saying that if you lower the virgin raw material or resource, I think there's an environmental savings, absolutely. But just the law of supply and demand, if you're not demanding as much now of that raw resource, is there a chance that the price of that resource will go up
Wouldn't
by those
wouldn't
businesses?
wouldn't the price go down if you were having less demand? Right?
Um,
No, I don't see how the price would go up if you have less
well,
demand.
I guess maybe it's not supply and demand. That's the wrong
Yeah,
law.
I think you're right.
But if there's less demand um, on a resource, those companies need to maintain their bottom line.
Yeah. Well,
Would they not increase the price?
well
Which
that that
which is a
that comes
violation of the
that
supply
that
and demand.
does come through a little bit in the model through the logistics chain. So basically,
Hmm.
interfirm trust
Okay.
is measured, and that
Yeah.
is the idea that you are not alone in this production. You're part of a network of other firms, and then the
Hmm.
idea is you want to build interfirm trust to reduce your logistics and get cooperation from these other firms to help you become more circular.
Right. Yeah. Somehow I think you'd need to be able to assist somehow to increase their bottom line. Um,
Yeah, well, that like I said, that can be part of the trust scenario. I haven't modeled
Yeah.
that in particular, but basically,
Mm.
you have this idea of, you know, through this trust measure, it's like you scratch my back, I'll scratch yours. So basically, you're
Mm.
trying to build trust with all of your logistics chain.
Yeah. Okay. Yeah, and like everything, there needs to be a value proposition.
Yeah.
Um,
But I do have another model I'm working on
mhm.
that specifically looks at supply and demand in this circular design.
Okay.
And how it does that is it says um, it says let's say you have a company that's introducing circular design, and then they have a certain price that they have to charge based on their manufacturing costs if they want to make a profit.
Yeah.
And
Yes.
then what the model is able to do is compare the price of the company with the
Mm.
circular design to their competitors, a competitor's price. And then
Okay.
when you compare the price of the company with the competitor's price, you can see an impact of supply and demand. So basically, because the price of the product may have to mark up from their manufacturing costs, it may be higher than their competition, and that may
Mhm.
reduce the demand for that product that the circular company is building.
Mhm.
However, one of the things that I try to measure in that model is some kind of a brand or a reputation idea where could a consumer actually want to buy a product from you for reasons other than price? They're willing to accept a
Yes.
price markup or a price margin just because you're doing good work with circular design.
Yeah.
So that's
Absolutely.
part of another model I'm working on right now, and like I
That,
said, I think that model is really excellent because it talks about competitive
yeah.
situations.
That would be interesting. Yeah. And I think where there's a savings to the environment, I think
Yeah,
definitely a
that could be
situation.
a very rewarding thing for a customer
Yeah,
to
absolutely.
know that
And I
their
think,
product
all of
is.
us, probably those of us in this call, we sometimes make that sacrifice,
Yeah,
where we will spend a little bit more for something that's cleaner on our environment.
or yeah, right.
Mm.
So the ADAPT SEM working group is working on a use case specifically in terms of adaptability um,
Right.
in
This,
terms of getting to using, I guess you could call it less of the Earth's resources.
Mm.
yeah, maybe I should present this to the adaptability working group because I think that the adaptability in this model is the design changes. Basically, you build a product and then you make design changes that adapt to a situation where you want to reduce the amount of a virgin material that you're extracting from the earth. So maybe the adaptability working group would be interested in that.
Well, I certainly are, and
Mm.
right.
Yeah,
Um,
I think what you're saying in adaptability, the way I can phrase the adaptability argument is that you're building a product that you can make design changes to improve. And so I think that's from what I know of the adaptability working group, I think that's sort of their goal is to build products that can be modified so that they're adaptable to new situations.
So there's, you get into innovation here as well. And so
Yeah.
you may want to be doing research in innovation. I like to think of um, the battery, the EV battery. If you can produce a battery that doesn't use rare earths elements, um, you've got advantages in several areas.
Yeah, for
Uh,
sure, for sure.
both from a scarcity of supply
Yeah,
So
Well,
basically, what's the cost
yeah,
plus the value,
yeah. And,
and it
and
gives
it,
you a competitive. I mean, it gives you a benefit in several different areas.
yeah, like
It
and
might be
in
the disposal.
my model, I do specifically have R&D investment. And basically, you can maybe play with the fraction of profit that is allocated to R&D investment. And R&D investment may lead to innovation that you're talking about, Ray.
Yeah, sometimes it's a matter of terminology, isn't it?
Yeah, yeah.
Yeah.
Any other questions? Herman, Art, Reza, Kevin,
Yeah,
JC.
I have a couple of questions. I have one question too. Uh, when we how do you compare what you are the resiliency here, or not? I mean the sustainability and the circular design compared to iterative methodology and data-driven iterative methodology. How do you compare that?
Yeah, well, I think, like I said, that's good. That's a good point. And like I said, the way the design upgrades are modeled here is that you collect performance data from the customers, and then you use that performance data to help you make design upgrades. And
Right,
so, that is, I think the idea there is that the upgrades are data driven, and
right.
they're based on data that's collected from the customer.
Yeah, but basically, as you know, the whole intention of real agile development is to bring it to the customer as soon as possible and bring it his response back to this next iteration and in order to. But one of the things that in iterative methodology is very important is the concept of risk analysis, because as you know, when you add a function or when you add some when you add a new function or enhancement to a existing system, you can you can have a side effect on all the existing function that exists. Therefore, having risk analysis with respect to see that impact is highly important. And one of the things that I don't see in this circular design, you are the relationship between these inputs that the impact rather either from environmental changes or which you can they can impact the so impact the as you said you have defined that when increasing increase in investment up to a point can increase the production, but up to the day it has the upper limit that. And now if you consider environment that you are also building this system, or one of the things that it was just discussed, or competition, or and then in the whole, when you bring that openness to the global environment, how do you control the circular design in the global environment, and in where your system is built in multiple different countries, multiple location, multiple manufacturing. Uh,
Yeah. Well,
it,
I think there's something, Reza, that I think you might be interested in. That it's called the rebound effect. And I can send you a video that describes the rebound effect. It's very, very interesting. And basically, it says that let's say we have a product, like in this case, where the price is reduced. So you save the client money. However, what the rebound effect says is that, well, saving money is great, but people will just spend it on something else.
right,
They're not going to just, put the money in the bank. They're going to actually spend it on something else. So they might have a replacement of your product with something else
Right. Yeah.
And so that's sort of an unintended consequence of recycling. And I think it's maybe a little bit like what you're saying is that, you have these risks that the good things you're doing may lead to other bad things that happen. Not
Right.
quite maybe the same as what you're saying, but I think you might be very interested in this research that's being done on the rebound effect.
Okay, thank you. And thank you for presentation. I learned here a lot. I appreciate that.
Yeah, that's great, right?
Yeah, thank you, Ivan. I mentioned this at the start of the presentation. I think I'm sharing my screen. But just to get it on the recording, I wanted to flash this on the screen and congratulate our past president and still board member, Ray Barton, for being recognized as an honorary member of the Professional Engineers of Ontario, and receiving the Order of Honor. This link shown on the screen leads you to a 3.5 minute video. We're out of time. I thought maybe I'd play it if we had extra time, but a really good video with a little interview with Ray. So just wanted to say one more time, Ray, congratulations. Well done.
Well,
Is that on LinkedIn, Ivan?
That's on LinkedIn. Yes.
Okay.
Yes. No.
thank you very much. I'm
Yes,
humbled.
thank you.
Okay. With that, I think we'll close out for this evening. I want to thank you again, Ivan, for yet another fabulous presentation. I think we're all quite fortunate to have you share your knowledge and your research work with us. So thank you, and
Thanks everyone for the great questions. They really were thoughtful.
yeah, everybody have a wonderful evening, and we'll see you at the next presentation, I hope.
Yeah.
Take care.
Thank you. Bye now.
Bye
So
now.
long, all.